Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Cloud Architect certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
Gencomart has built a version of their application on Google Cloud Platform that serves traffic to Asia. You want to measure success against their business and technical goals. Which metrics should you track? The options are: Option A, error rates for requests from Asia. Option B, latency difference between US and Asia. Option C, total visits, error rates, and latency from Asia. Option D, total visits and average latency for users from Asia. Option E, the number of character sets present in the database.
To arrive at the correct answer, we focus on the keywords: serves traffic to Asia, measure success, business and technical goals.
The correct answer is option C, total visits, error rates, and latency from Asia.
Why is this correct? C. Tracking total visits evaluates business success, while monitoring error rates and latency evaluates technical success such as reliability and performance for the Asia deployment. Why are the others incorrect? A. Focusing solely on error rates measures technical reliability but ignores business metrics like user adoption and performance metrics like latency. B. Comparing US and Asia latency does not evaluate whether the Asia-specific deployment meets its designated business and technical metrics. D. Total visits and average latency measure business adoption and performance, but omit error rates required to measure technical reliability. E. Database character set count is a schema configuration detail and is unrelated to business adoption or technical performance metrics.
Gencomart wants to move their user profiles database to Google Cloud Platform. Which Google database should they use? The options are: Option A, Cloud Spanner. Option B, Google BigQuery. Option C, Google Cloud SQL. Option D, Google Cloud Data Store.
To arrive at the correct answer, we focus on the keywords: move their user profiles database to Google Cloud Platform. Which Google database should they use?
Correct answer is option D, Google Cloud Data Store.
Why is this correct? D. Google Cloud Data Store is a fully managed, highly scalable NoSQL database designed for web applications, making it ideal for storing schemaless user profile data with fast key-value lookups. Why are the others incorrect? A. Cloud Spanner is a globally distributed relational database for mission-critical transactional workloads, making it complex and cost-ineffective for simple user profile storage. B. Google BigQuery is a serverless data warehouse built for analytical queries, OLAP, over massive datasets, not for real-time operational database workloads like user profile management. C. Google Cloud SQL is a managed relational database service for structured data, which lacks the flexible schemaless structure and automatic horizontal scaling needed for user profiles.
For this question, refer to the Helicopter Racing League, HRL, case study. Your team is in charge of creating a payment card data vault for card numbers used to bill tens of thousands of viewers, merchandise consumers, and season ticket holders. You need to implement a custom card tokenization service that meets the following requirements: It must provide low latency at minimal cost. It must be able to identify duplicate credit cards and must not store plaintext card numbers. It should support annual key rotation. Which storage approach should you adopt for your tokenization service? The options are: Option A, store the card data in Secret Manager after running a query to identify duplicates. Option B, encrypt the card data with a deterministic algorithm stored in Firestore using data store mode. Option C, encrypt the card data with a deterministic algorithm and shard it across multiple memory store instances. Option D, use column-level encryption to store the data in Cloud SQL.
To arrive at the correct answer, we focus on the keywords payment card data vault, low latency at minimal cost, identify duplicate credit cards, must not store plaintext card numbers, annual key rotation.
The correct answer is option B, encrypt the card data with a deterministic algorithm stored in Firestore using data store mode.
Why is this correct? B. Firestore in data store mode offers high availability, autoscaling, and low latency at minimal cost. Deterministic encryption produces identical ciphertexts for identical card numbers to identify duplicates without storing plaintext, supporting annual key rotation via Cloud KMS. Why are the others incorrect? I. Secret Manager is designed for managing configuration secrets and API keys, not for querying or indexing transactional card data to identify duplicate credit card entries efficiently at scale. C. Memory Store is an in-memory Redis/memcached cache and lacks native durable persistence for a payment card vault. Sharding across multiple instances increases costs and operational overhead. D. Cloud SQL requires provisioned database infrastructure, resulting in higher baseline costs and complex scaling. It is less cost-effective for simple, low-latency key-value token lookup workloads compared to Firestore.
For this question, refer to the Helicopter Racing League (HRL) case study. The HRL development team releases a new version of their predictive capability application every Tuesday evening at 3 a.m. Universal Time, coordinated to a repository. The security team at HRL has developed an in-house penetration test cloud function called Airwolf. The security team wants to run Airwolf against the predictive capability application as soon as it is released every Tuesday. You need to set up Airwolf to run at the recurring weekly cadence. What should you do? The options are: Option A, set up cloud tasks and a cloud storage bucket that triggers a cloud function. Option B, set up a cloud logging sync and a cloud storage bucket that triggers a cloud function. Option C, configure the deployment job to notify a pub/sub queue that triggers a cloud function. Option D, set up identity and access management (IAM) and confidential computing to trigger a cloud function.
To arrive at the correct answer, we focus on the keywords releases a new version, as soon as it is released, recurring weekly cadence.
The correct answer is option C, configure the deployment job to notify a pub/sub queue that triggers a cloud function.
Why is this correct? C. Configuring the deployment job to publish a message to a pub/sub topic upon completion enables event-driven execution of the cloud function immediately after a new version is released. Why are the others incorrect? A. Cloud Tasks manages task queues and execution scheduling, but does not provide an event-driven mechanism to detect deployment releases or directly trigger cloud functions via storage. B. Routing logs to cloud storage via a logging sync creates an inefficient, multi-step pipeline with added latency instead of directly triggering a function upon release. D. IAM controls access permissions and confidential computing encrypts memory in compute instances, neither handles event notification or automated function invocation.
For this question, refer to the Helicopter Racing League (HRL) case study. HRL wants better prediction accuracy from their ML prediction models. They want you to use Google's AI platform so HRL can understand and interpret the predictions. What should you do? The options are: Option A, use Explainable AI. Option B, use Vision AI. Option C, use Google Cloud's Operations Suite. Option D, use Jupyter Notebooks.
To arrive at the correct answer, we focus on the keywords ML prediction models, Google's AI platform, understand and interpret the predictions.
The correct answer is option A, use Explainable AI.
Why is this correct? A. Explainable AI on Google Cloud's AI platform provides feature attributions and interpretability tools to help understand and interpret how machine learning model predictions are made. Why are the others incorrect? B. Vision AI is designed specifically for computer vision tasks like image labeling and object detection, not for interpreting or explaining predictions of custom machine learning models. C. Google Cloud's Operations Suite is used for monitoring, logging, and application performance management of GCP infrastructure and services, not for ML model interpretability. D. Jupyter Notebooks are interactive development environments used for writing code and exploratory data analysis, but do not inherently provide built-in ML model explainability tools.
For this question, refer to the Helicopter Racing League (HRL) case study. HRL is looking for a cost-effective approach for storing their race data such as telemetry. They want to keep all historical records, train models using only the previous season's data, and plan for data growth in terms of volume and information collected. You need to propose a data solution. Considering HRL business requirements and the goals expressed by CEO S. Hawk, what should you do? The options are: Option A, use Firestore for its scalable and flexible document-based database. Use collections to aggregate race data by season and event. Option B, use Cloud Spanner for its scalability and ability to version schemas with zero downtime. Split race data using season as a primary key. Option C, use BigQuery for its scalability and ability to add columns to a schema. Partition race data based on season. Option D, use Cloud SQL for its ability to automatically manage storage increases and compatibility with MySQL. Use separate database instances for each season.
To arrive at the correct answer, we focus on the keywords: cost-effective approach for storing their race data such as telemetry, keep all historical records, train models using only the previous season's data, plan for data growth in terms of volume and information collected.
The correct answer is option C, use BigQuery for its scalability and ability to add columns to a schema. Partition race data based on season.
Why is this correct? C. BigQuery is a cost-effective data warehouse for high-volume telemetry analytics. It easily adapts to evolving schemas by adding columns and supports table partitioning by season, enabling efficient, low-cost data isolation for machine learning model training. Why are the others incorrect? A. Firestore is a NoSQL document database built for web and mobile transactional workloads. It is not designed or cost-effective for large-scale telemetry data storage, complex analytical processing, or ML training. B. Cloud Spanner is an enterprise OLTP database built for global transactional consistency. It is cost-prohibitive and suboptimal for storing massive historical telemetry data intended for analytical queries and machine learning. D. Cloud SQL is a relational OLTP database that does not scale easily for high-volume analytics. Managing separate instances per season adds significant operational overhead and unnecessary infrastructure cost.
For this question, refer to the Helicopter Racing League (HRL) case study. A recent finance audit of cloud infrastructure noted an exceptionally high number of compute engine instances are allocated to do video encoding and transcoding. You suspect that these virtual machines are zombie machines that were not deleted after their workloads completed. You need to quickly get a list of which VM instances are idle. What should you do? The options are: Option A, log into each compute engine instance and collect disk, CPU, memory, and network usage statistics for analysis. Option B, use the Cloud Compute Instances list to list the virtual machine instances that have the idle, true label set. Option C, use the Cloud Recommender command to list the idle virtual machine instances. Option D, from the Google console, identify which compute engine instances in the managed instance groups are no longer responding to health check probes.
To arrive at the correct answer, we focus on the keywords: video encoding and transcoding, zombie machines that were not deleted, quickly get a list of which VM instances are idle.
The correct answer is option C, use the Cloud Recommender command to list the idle virtual machine instances.
Why is this correct? C. Google Cloud Recommender automatically analyzes resource usage metrics to detect idle virtual machines. Using Cloud Recommender provides an immediate, centralized list of recommendations for idle VM instances quickly and efficiently. Why are the others incorrect? A. Manually logging into each instance to inspect system statistics is extremely time-consuming and inefficient for quickly auditing cloud infrastructure. B. Google Cloud does not automatically assign an idle, true label to VM instances, making label-based filtering ineffective for finding idle machines. D. Health check failures identify unresponsive or failed instances, not idle instances that are operating normally but running without active workloads.
For this question, refer to the EHR Healthcare case study. You are responsible for ensuring that EHR's use of Google Cloud will pass an upcoming privacy compliance audit. What should you do? Choose 2. The options are: Option A, verify EHR's product usage against the list of compliant products on the Google Cloud Compliance page. Option B, advise EHR to execute a Business Associate Agreement, BAA, with Google Cloud. Option C, use Firebase authentication for EHR's user-facing applications. Option D, implement Prometheus to detect and prevent security breaches on EHR's web-based applications. Option E, use GKE private clusters for all Kubernetes workloads.
To arrive at the correct answer, we focus on the keywords: EHR's use of Google Cloud, privacy compliance audit. Choose 2.
The correct answers are Option A, verify EHR's product usage against the list of compliant products on the Google Cloud Compliance page. And Option B, advise EHR to execute a Business Associate Agreement, BAA, with Google Cloud.
Why is this correct? A. Verifying product usage against Google Cloud's compliance page ensures that only services certified for HIPAA compliance are used for handling protected health information, PHI, which is required for audit verification. B. Executing a Business Associate Agreement, BAA, with Google Cloud is legally mandatory under HIPAA for healthcare organizations to process and store protected health information, PHI, compliant with privacy regulations. Why are the others incorrect? C. Firebase authentication provides identity management but does not satisfy overall regulatory compliance requirements for storing or processing PHI across application services. D. Prometheus is a metrics logging and monitoring tool, not an intrusion detection or security prevention solution required for privacy compliance audits. E. While private clusters improve network security, using GKE private clusters for all Kubernetes workloads is not a regulatory requirement for passing a HIPAA privacy audit.
For this question, refer to the EHR Healthcare case study. You need to define the technical architecture for securely deploying workloads to Google Cloud. You also need to ensure that only verified containers are deployed using Google Cloud services. What should you do? Choose 2. The options are: Option A, enable binary authorization on GKE, and sign containers as part of a CI/CD pipeline. Option B, configure Jenkins to utilize Credes to cryptographically sign a container as part of a CI/CD pipeline. Option C, configure Container Registry to only allow trusted service accounts to create and deploy containers from the registry. Option D, configure Container Registry to use vulnerability scanning to confirm that there are no vulnerabilities before deploying the workload.
To arrive at the correct answer, we focus on the keywords: securely deploying workloads, only verified containers are deployed using Google Cloud Services. Choose 2.
The correct answers are Option A, enable binary authorization on GKE, and sign containers as part of a CI/CD pipeline. And Option D, configure Container Registry to use vulnerability scanning to confirm that there are no vulnerabilities before deploying the workload.
Why is this correct? A. Binary authorization is a native Google Cloud service for GKE that enforces deploy time security policies by ensuring only cryptographically signed and verified container images are deployed. D. Container Registry vulnerability scanning automatically inspects container images for known vulnerabilities prior to deployment, helping ensure only secure workloads are deployed. Why are the others incorrect? B. Credes is an open-source tool, whereas the requirement specifically asks to deploy and verify container images using native Google Cloud services. C. Restricting service account access controls registry permissions but does not cryptographically verify container signatures or scan images for vulnerabilities.
You need to upgrade the EHR connection to comply with their requirements. The new connection design must support business-critical needs and meet the same network and security policy requirements. What should you do? The options are: Option A, add a new dedicated interconnect connection. Option B, upgrade the bandwidth on the dedicated interconnect connection to 100G. Option C, add 3 new cloud VPN connections. Option D, add a new carrier peering connection.
To arrive at the correct answer, we focus on the keywords: upgrade the EHR connection, support business-critical needs, same network and security policy requirements.
The correct answer is option A, add a new dedicated interconnect connection.
Why is this correct? A. Adding a new dedicated interconnect connection provides physical link redundancy across distinct locations, achieving 99.99% high availability for business-critical workloads while maintaining strict private network security policies. Why are the others incorrect? B. Upgrading bandwidth increases throughput capacity but fails to provide physical link redundancy or eliminates single points of failure required for business-critical reliability. C. Adding cloud VPN connections routes traffic over the public internet, violating the strict private network and security policy requirements satisfied by dedicated interconnect. D. Carrier peering provides access to Google public services over enterprise providers rather than extending private RFC 1918 VPC address space, failing security policy requirements.
For this question, refer to the EHR Healthcare case study. You need to define the technical architecture for hybrid connectivity between EHR's on-premises systems and Google Cloud. You want to follow Google's recommended practices for production-level applications. Considering the EHR healthcare business and technical requirements, what should you do? The options are: Option A, configure 2 partner interconnect connections in one metro, city, and make sure the interconnect connections are placed in different metro zones. Option B, configure 2 VPN connections from on-premises to Google Cloud, and make sure the VPN devices on-premises are in separate racks. Option C, configure direct peering between EHR Healthcare and Google Cloud, and make sure you are peering at least 2 Google locations. Option D, configure 2 dedicated interconnect connections in one metro, city, and 2 connections in another metro, and make sure the interconnect connections are placed in different metro zones.
To arrive at the correct answer, we focus on the keywords: technical architecture for hybrid connectivity, Google's recommended practices for production-level applications.
The correct answer is option D, configure 2 dedicated interconnect connections in one metro, city, and 2 connections in another metro, and make sure the interconnect connections are placed in different metro zones.
Why is this correct? D. Google Cloud's recommended practice for 99.99% production-level availability requires 4 dedicated interconnect connections deployed across 2 distinct metros, with 2 connections in different zones per metro to guarantee fault tolerance and high availability. Why are the others incorrect? A. Configuring 2 connections in a single metro provides a maximum of 99.9% availability, which does not meet Google's 99.99% SLA recommendation for production-critical applications requiring multi-metro redundancy. B. Cloud VPN does not offer the enterprise bandwidth or SLA guarantees of dedicated interconnect, and 2 VPN connections fail to achieve the 99.99% high availability topology required for production workloads. C. Direct peering reaches Google public endpoints over public IP space rather than providing private, SLA-backed cloud interconnect connectivity into internal VPC networks.
For this question, refer to the EHR Healthcare case study. You are a developer on the EHR Customer Portal team. Your team recently migrated the Customer Portal application to Google Cloud. The load has increased on the application servers, and now the application is logging many timeout errors. You recently incorporated pub/sub into the application architecture, and the application is not logging any pub/sub publishing errors. You want to improve publishing latency. What should you do? The options are: Option A, increase the pub/sub total timeout retry value. Option B, move from a pub/sub subscriber pull model to a push model. Option C, turn off pub/sub message batching. Option D, create a backup pub/sub message queue.
To arrive at the correct answer, we focus on the keywords: application is logging many timeout errors, pub/sub, improve publishing latency.
The correct answer is option C, turn off pub/sub message batching.
Why is this correct? C. Turning off pub/sub message batching ensures messages are sent immediately instead of being buffered to meet batch thresholds, thereby reducing individual message publishing latency. Why are the others incorrect? A. Increasing the total timeout retry value allows retries to continue longer during failures, which tolerates high latency rather than improving publishing latency. B. Switching from a pull to a push subscriber model affects downstream consumption, which has no impact on producer publishing latency. D. Creating a backup pub/sub queue adds infrastructure redundancy but does not resolve client-side batching delays or improve publishing latency.
For this question, refer to the EHR Healthcare case study. In the past, configuration errors put public IP addresses on back-end servers that should not have been accessible from the internet. You need to ensure that no one can put external IP addresses on back-end compute engine instances and that external IP addresses can only be configured on front-end compute engine instances. What should you do? The options are: Option A, create an organizational policy with a constraint to allow external IP addresses only on the front-end compute engine instances. Option B, revoke the compute.network admin role from all users in the project with front-end instances. Option C, create an identity and access management (IAM) policy that maps the IT staff to the compute.network admin role for the organization. Option D, create a custom identity and access management (IAM) role named GCE_frontend with the compute.addresses.create permission.
To arrive at the correct answer, we focus on the keywords: ensure that no one can put external IP addresses on back-end compute engine instances. External IP addresses can only be configured on front-end compute engine instances.
The correct answer is option A, create an organizational policy with a constraint to allow external IP addresses only on the front-end compute engine instances.
Why is this correct? A. Organization policy provides central governance constraints, specifically constraints/compute.vm external IP access, which can restrict external IP address attachment exclusively to specified allowed compute engine instances, front-end, while systematically blocking all back-end instances. Why are the others incorrect? B. Revoking IAM roles limits overall administrative permissions but does not enforce resource-level constraints. It prevents necessary management of front-end instances without enforcing policy controls on IP configuration. C. Granting compute.network admin at the organization level provides broad network administration access, which increases privilege scope and does not restrict external IP assignment for specific back-end instances. D. Creating a custom IAM role controls permission to reserve IP addresses, but IAM permissions cannot enforce resource-specific configuration rules to restrict external IP attachment exclusively to front-end instances.
For this question, refer to the EHR Healthcare case study. You are responsible for designing the Google Cloud Network architecture for Google Kubernetes Engine. You want to follow Google best practices. Considering the EHR Healthcare business and technical requirements, what should you do to reduce the attack surface? The options are: Option A, use a private cluster with a private endpoint with master authorized networks configured. Option B, use a public cluster with firewall rules and virtual private cloud (VPC) routes. Option C, use a private cluster with a public endpoint with master authorized networks configured. Option D, use a public cluster with master authorized networks enabled and firewall rules.
To arrive at the correct answer, we focus on the keywords Google Kubernetes Engine, Google Best Practices, reduce the attack surface.
The correct answer is option A, use a private cluster with a private endpoint with master authorized networks configured.
Why is this correct? A. Using a private cluster with a private endpoint ensures worker nodes and the control plane have no public IP addresses. Master authorized networks further restrict control plane access to authorized internal IP ranges, drastically reducing the attack surface per Google Cloud Best Practices. Why are the others incorrect? B. A public cluster assigns public IP addresses to nodes, exposing them to the internet and increasing the attack surface. Relying on firewall rules and VPC routes on a public cluster is suboptimal for high-security healthcare compliance. C. Using a public endpoint leaves the control plane accessible over the public internet. Although master authorized networks restrict traffic by IP, a private endpoint completely avoids public internet exposure, providing stronger protection and a smaller attack surface. D. Public clusters expose nodes directly to the internet via public IP addresses. Combining master authorized networks and firewall rules on a public cluster does not achieve the minimal attack surface provided by a private cluster with a private endpoint.
Mount Kirk Games wants you to design their new testing strategy. How should the test coverage differ from their existing backends on the other platforms? The options are: Option A, tests should scale well beyond the prior approaches. Option B, unit tests are no longer required, only end-to-end tests. Option C, tests should be applied after the release is in the production environment. Option D, tests should include directly testing the Google Cloud Platform (GCP) infrastructure.
To arrive at the correct answer, we focus on the keywords Mount Kirk Games, new testing strategy, test coverage differ from their existing backends.
The correct answer is option A, tests should scale well beyond the prior approaches.
Why is this correct? A. Mount Kirk Games anticipates rapid global growth and unpredictable user traffic on GCP, requiring load and performance testing to scale far beyond prior backend approaches to ensure system stability under massive demand. Why are the others incorrect? B. Unit tests remain essential for validating individual software components and business logic, regardless of the cloud architecture or platform used. C. Software testing must occur in development and staging environments prior to production release to detect bugs early and avoid customer impact. D. Google Cloud manages and tests its underlying platform infrastructure under the shared responsibility model, so direct testing of GCP infrastructure is unnecessary and out of scope.